Good evening to everybody. My name is Dr. Tim. Today, we shall continue from where we stopped last time on our class on the course, class computing. Like I said earlier, I told you that time that there are some preliminary topics that you need to understand, which will make us to go advance to the main course. And that is why I try to brush some aspect of machine learning with you. Today also, I'll try to still brush it up before I now go to how to develop a web app in the cloud. Now, let me share my screen with you so that I'll be able to have access to what I'm doing. Please. I think you have all seen my screen. Have you all seen my screen, please? Let me hear your voice if you have seen my screen.
Yes.
Yes.
Yes, sir.
All right, that's good. So you can see,
Last time that's it.
Last time I met you, I discussed little part of machine learning under classification, and I want to continue the same thing today. But last time we made use of data sets in the Python library. That data set is under, I think it was data on Titanic, and that was embedded inside the library called Seaborn in Python. But today, I want to teach you how you can get data. If data is already on your computer, how you can import it from your computer into this Python environment and begin to solve the problem thereafter. Now, the first thing you have to do is to import this library. Each of this library has functions. If you look at this import warning.filter warnings in null. So under Jupyter Notebook, I'm using Jupyter Notebook now, not VS Code. So Jupyter Notebook usually give us some warnings at times when the solution is already solved, to still give some warnings. So I want system to ignore all those warnings. That is why I put this line of code here, this line of code. Then another one is import NumPy as NP. NumPy is a library in Python, and the meaning of NumPy means number Python. So NumPy, I want it to be represented as NP. That means wherever I want to use NumPy, I will write NP. I want to write NP, it means that I'm referring to NumPy. Another one is pandas. Then I represent as what? As PD. Then we have matplotlib.pyplot as PAT. We have Seaborn, we have ggplot, and so on and so forth. All these libraries, they are very important for you to put them in the first place. So now, after this library, after you have installed this library, you have run it, you can see this library running. That's why you can see the result, the one you're seeing here. This one you are seeing here means that I have run this cell of library. If you didn't see any number here, this one you are seeing here, if you didn't see it here, it means that I have not run this cell. That's the meaning. And if you see asterisk means that you should hold on, that system is busy running that particular cell. Anytime you see asterisk, it means that system is busy running that cell. So the specification of my computer is 32 gig. So, but the minimum specification you will use for this our work is 8 gig RAM. So ensure you get 8 gig RAM system. Either you are using Windows, Linux, or what have you. So ensure that it is minimum of 8 gig RAM because of the type of work we want to use to do. So after running the library, the next thing I want you to know is your working directory. What is the meaning of working directory? Working directory means that the data sets, your data sets, where it is being saved, or your code, where it is being saved on your computer. By the time you write the code in Jupyter Notebook, where is it being saved? Where are all your code being saved? Where is your working directory for this interface, IDE? So how do you get working directory? You type this percentage and PWD. By the time you type that, you run it. When I run it, you can see the result it's giving me. It's giving me the result as C. That means my working directory is in C. When I open my C file in my computer, I will see users starting with capital U, but the rest letters are small letters. After that, I will see user again. That's capital letter. So it is this inside this user that all my file are present. So this reason why I'm telling you this is because the file, the data that you want to import into this place, that is where you are going to keep it. Each computer has different directory. If you check your own directory, your own might be different from my own completely. So it depends on how your system is being configured. It's being configured. So in the meantime, the next thing now for you to do is that I want to import this data to call healthcare data stroke. Because look at my topic. My topic is talking about modeling the stroke data with machine learning algorithm. Stroke, I want to model the stroke. I want to know which the type of stroke that this stroke now, you can see that this stroke now is talking about classification. Okay, anyway, like I said my last video, I told you that when you have data sets, sometimes your objective will determine the type of machine learning to be applied. And last time I told you, from what I said last time, I said if you have a dependent variable in your data, if you have target variable, that's your target variable. That is why you usually call it Y in statistics. If you have that particular value in your data set, that means you will be thinking of supervised machine learning. But if you don't have that target variable, you'll be thinking of unsupervised machine learning. Now, I said supervised machine learning also divided into two. If your target variable is categorical, that is like yes or no, true or false, dead or alive, and so on and so forth, that's categorical. Or maybe it is like agree, disagree, and undecided. That is still categorical. It's still categorical. So if your response variable, that is your Y, your target variable is categorical, then you think of classification. That means you want to classify the results. But if your target variable is a discrete continuous value, that is like 1.7, like the age of student, 1.7, 17, 18, 22, 33, 26, 21, 25, all those values, they are called discrete continuous variable. So if that is what you have in your target variable, then you make use of regression. And that regression is what I want to do tomorrow, and also go into the web app. So, but for today, I will completely teach you this because I'm going to give you assignments where you're going to make use of all these things I'm doing. And then it's when that go above my training, at least will fetch more mark. The more deeper you go, the more mark you get in your assignments. So that's why I'm trying to give you all these things. Now, this is a code, DF. It's equal to DF here. I decided to write DF here. That's a frame. If you want to write your own code, please don't write DF for me. Write your own name here. If you write your own name here, that will give you much flesh in my grading. So you can put your own name here, maybe like Tim, like Ezekiel, like TJ, like Okoye, and so on and so forth. So let your name be here instead of DF. Then the next thing is that you now write pd dot read underscore CSV. If the data set is in CSV format, then we now go to your what? To your working directory. Let me now cancel it now. I want to close this one now. I'm trying to delete it. Look what I want to do. I will now go to my working directory. Where is my working directory? So I will now go into working directory. So let me go and show you my working directory. This is my working directory. Can you see now? This is my working directory. I've gone to what? This is look at this C. This is user. This is user. What I told you last time. This is C file. Look at this. This is my file. Can you see this?
Yes, I have your working directory. I don't know if it's my network.
We can see your screen, sir.
You can see.
We can.
Yeah, we can see your screen.
Okay. You
Maybe
see my
it's
screen.
like you're not sharing your entire screen.
No problem. You will see my screen now. You see my screen now. Okay. Can we see my screen now?
Yes.
Yes, but not where you are
Yes.
talking.
Yes, sir. Yes, sir. That's it.
This is my local DC. So if you click, if you open this C file now, it will show you this. Do you see what it shows you? Do you see what it shows you? What is this? Who can tell me this?
Users.
So users, this is where I'm going. You click on users again, it will give you this user again. So you now click on this again. So this is my working directory now. I think you can see it now.
Yes, sir.
Yes, sir.
This is my working directory. Good.
Yes, sir.
So
Yes,
I'll
sir.
look for that file. That file is called healthcare stuff, healthcare, something like that. I'll see it now. Now, as I'm moving down now, I will see the file. The file is in Excel format. It's in healthcare. That is healthcare. Where is healthcare? Healthcare. The file is healthcare. Do you have the file here? Healthcare. I think it's not here now. Can you see? I didn't see the file here. Healthcare. Good. I will now go to my my file where my computer where I keep the file before. This is where I keep the file before. Do you see this now? You now copy it. When you copy it, you now go to this black. When you get here, can you see now? When you get here, when you get to the user, this user file, you will now paste it, Control V. So when I paste it, this is the file. Can you see? Can you see it now? Has anybody seen me?
Yes, you can see it.
Yes, I can see
I can see it. Yeah.
Now the file. So you will now click on that file like this, the way I click on it. After clicking on it like this, the next thing you have to do is that you now go up here. What do you see here? What is this?
Cut.
What? What is this?
Copy part.
Copy part.
You now click on copy parts. Remember that I told you you must place your cursor on this file here. That is, your cursor must be on this file like this. On this file, healthcare data set stroke data. That's the data I want to get. You now go to your copy parts. You click on it. Now I've copied the parts because I've clicked on it. So I've copied the part now. I've clicked on it now. So you now go back to your what? Now go back to your code, to your working environment where you have in your code. You now go back to your code. Did you see my Python? I mean my digital book code here.
Yes.
Can you see it? Can you see it?
Yes.
Good. You can write df is equal to pd.read_csv. So after that, inside that brackets, you will now press Control V. Control V will now paste that file. To now paste that copy part to paste it itself. I think you are with me.
Well,
so
yes,
that means my home must be different from your home. Who can tell me the reason? The reason is that the working directory of every computer is different. So all these areas you are seeing here, they must be different. Your home may involve the document, from document go to user, from here, so your home may involve that. So it depends on the computer you are using.
Try it again.
Your home here may be different from my home. This thing I pasted here now, your home may be different from my home. So don't say your home is different from my home and that's why you cannot continue. No. Surely your home should be different or may be different from my home. The reason is that if your working directory is not the same with me, with my home system, so definitely your home will be different from my home. The bottom line is that the basic thing is that you need to understand how I got to this place. Once you understand that, you put that thing to practical, and you go to walk yourself around the place. Any question, please? So as I'm looking at this code, there is one error there, but I won't tell you the error until I run it. I want to run the code now so you can see the error I'm talking about. If I correct it now before I run the error, if I correct it now before I run it, you will not know the error if you want to do your own practical. So now
the forward slash.
Yes, the first class. What happened to it?
Yes, it will not run except you use the arrow or you turn it to face the right.
Exactly. So this is what we call Unicode escape. Unicode escape means that your slash has to change to the right one, to face the right direction. This one too has to change. This one too has to change. So those are the errors that I observed there from the beginning. But I run it now, so you are getting the results. Why? Okay, PD is not defined. Can you see? PD is not defined means that I have not run this cell of code. So we haven't defined the PD. Can you see what I'm saying now? This is running now. So let me now run this PD. Let me now run this now. So this is the starter sets. So that set now has appeared. So df.ed we show the first 5 data sets. So if you want it to be 10, the first 10, you put 10 inside the bracket here. You run like this. So the first 10 will show. Look at it, the first 10. The first 10 will show. Can you see now? So if I want 20 to be show, I will put 20 here. The first 20 to show. So the first 20 will show. Can you see now? This is the first 20. The first 20 are shown. Can you now see? So now the next thing is what? We want to go into EDA. What is EDA?
Sorry, sir, I have a question with the last step.
Okay.
So maybe I missed something. Why is this step relevant? Because in our previous class, we just download the file on our computer and then upload it on Jupyter Notebook. So the step
just joining.
No, I'm not joining, but I didn't quite get the reason why you're doing what you're doing.
Okay, I noticed that you just joined the class again. Maybe you are off the line. But anyway, I will use a minute to explain to you because I want to carry almost everybody along. So the reason why this is necessary is because the last time I did for you, we used the data sets that is embedded inside Python library called Seaborn. That data set was picked from the library that's available inside the Python environment. So that data set is called Titanic. So we have some data set inside that library called Seaborn. But now, this place now, you are given data sets which has already been typed in Excel and has already been saved in CSV format. Can you see now? This has been saved in what? CSV. That's why you have .csv here in the front. So we want to now import such data from Excel into what? Into the Python environment. So that is what I'm doing. The last class, we used data set that's already available inside the Python, and that is the library called Seaborn. But today, you are given a data set that is not inside this environment. It's already outside. So you want to import it from that outside into this environment. That's what I've done. I think I've answered your question.
Yes, sir. Thank you.
All right. So the next thing now is to conduct what is called EDA. EDA is the first thing you have to do when you want to do any analysis. And what does EDA means? Exploratory data analysis. So that means you begin to check the variables one by one. Which out of these variables are categorical and which of them are what? Are numbered. So if I remove this one now again, and I run this again, I want to see the first 4, the first 5. You can see that you have this ID. The ID here shows that just arbitrary number, ID number, like your matric number. Like your matric number in the university, it's arbitrary. So if you have matric number of 001, 001 doesn't mean that you'll be the first in the class. In fact, somebody have my number 001 may maybe even be the most poorest student among all. So that number is arbitrary. So and it does not have any correlation with the main work. So the first thing now again was gender, and gender is what I want to analyze now. I want to analyze the gender. You know, gender, of course, has to do with either male or female. So and that's what we are having there. So you have prints, DF, then gender dot value underscore count. You put this one there. Then you now have print DF. If I run this code line by line, you will see what I'm talking about. If I run this code line by line, let me run this first line now. This is the first line I'm running. You want to create more cell under this place. You come to this place, this plus. You create more cell. This is the second one. You know, last time I put it together. So this second one, this first one now shows that what? It shows the counts. Female is having 2,994. Male is having 2,115. Others having 1. That is, some people pick others when they were filling the form. They pick others. That's why you have others 1. Now I want to now separate it and have the percentage. And that's what I want to have now, percentage. So what is the percentage of male and female? That is code I've written for you now. Can you see DF? If what you have used in this place is your name, maybe Eze, you put Eze here, you put Eze dot ed here. You know, I have warned you that you not use DF. So if anybody use DF for me and submit the assignment, I'll give you 0. That's not automatic, it's 0. So you have to use your name, your rename, and let me see that you are the one talking to me, not DF. So in this place now, you are writing this code, DF. If what you have used is essay, you put essay, bracket gender dot value underscore counts. Then put open and close brackets. Then slash sum, DF gender dot value this times 100. This asterisk means times 100. So that means convert the value, divide the value of each gender by total gender, then multiply by 100. So we have 58.59% are female, 41.39 are male, while 0.01% are what are others. And that's what I've done. Now this place also, I want to display this thing in pie charts. That's what I want to do here. Can you see my results? See my result now in pie charts. Can you see male, female, and others? This female, this male, and this others. This code here is giving you that this 0.1 here, this 0.1 you are seeing here is giving you that convert it to what? To 1 decimal places. So if I put 0.2 now, 0.2, now I run the code again. Can you see what's giving me? It's giving me 58.59. What about this place? 41.39. So if I put 0.3 here now, 0.3 to take me towards 2 decimal places, can you see? 58.591, 41.389. I think you can see the way I write the code. So if you have any question about the code, then you can let me know. Then 0.2 is what I want. I put 0.2 here. So now this place now, you now copy this because you want to write your reports. You give me your code. When I give you assignments, you give me your code separately. Then you write your report in Excel, in Microsoft Word. You copy this image. So when you want to do your analysis, the first thing is that you talk about data set, data description. You talk about the topic you are choosing. You talk about the topic that is on your introduction. Talk about the topic. Then, okay, anyway, that's what you want to do your project is when you have. You need all those ones. But in your assignments, the first thing is that in your assignments, I want to see a brief introduction. Brief also, what I mean that like 2 or 3 paragraphs. You talk about your introduction. We talk about the probably the mini topic you are choosing. Look at this heading now. That is modeling the stroke data set with machine learning algorithm. So that means you talk about the modeling, talk about the stroke. So at least with 2 or 3 paragraphs is okay. So when you talk about that, so the next thing is that you now go straight to your data analysis, and that is the first thing is EDA. So when you want to call it by EDA, you talk about gender. If you put down gender, so your gender, okay, sorry, before you go to EDA, you must say something about your data you are using. You must say something about the data you are using. So how do you say something about the data you are using? This is the way, though I did not include that. I did not include that in your this thing. I did not include that in your code I gave you. So the code is df.info bracket open and close bracket. This info will give you the information about data set you want to use. So the first thing is ID, and that ID is what is a null, is a non-null, the integer 64 objects. Then gender, age, hypertension. So that means if I were you now, I'll talk about this data set now. You just say this data set has 12 columns. The first column is gender, followed by, sorry, the column is ID, followed by gender and age. Hypertension is the fourth column. Then at deceased is the fifth column. Ever married is the sixth column. So you begin to list them like that, and you tell me that the number of entries, number of rows is 5,110. That's the number of rows. So that's the number of rows. So that means you are telling me something about data sets. After that, you now go into your EDA. Your EDA, you now pick the variable one by one and discuss it. When you pick gender variable, you tell me what you see in your results. The gender is a three-phase or three-locate variable, which is classified into male, female, and others. So 2,994 females and 22,115 males with only one as other. So in this case, the percent, you not talk about percentage. Percentage of male is this, out of male is this. Then you have the diagram. Now show me the diagram. This image will be copied here and taken to the word format. So you will discuss gender. What you see in there, discuss it for me in your diagram, in your Microsoft Word. So that is gone. Now we go to another one. Gender again. You may choose not to use pie charts. You may choose to use something different from pie charts. That is probably you may choose something that's different from pie charts, and that is bar charts. Bar charts. You can see the bar charts. So if you can draw more beautiful bar charts, there are some code that you can look for that will give you more beautiful bar charts. That will give you the number and percentage in this top here. The number will show here. Percentage will show. Number will show your percentage. So, or the number will show inside this column, this place now. The number of what? The number of male will show inside. Number of male will show inside. Then give you different colors. This is all here, different colors. Go and look for a beautiful code. So this is just a guide for you. So from there we go to age. How do you do the age? The age is continuous because the age look like 10, 15, 20, 5, all these things. So you run the age and you have these results in your age. And also you talk about hypertension. Hypertension. So look at the hypertension. That one is also talking about categorical. We have a 0. The 0 is for what? The 0 is for hypertension. Then 1 is for what? 1 is for 0 is for no hypertension. 1 is for having hypertension. So this is what you have here in your code. And you can see the percentage. And also see, this code you can also divide into 2. This code. So you can see the percentage and you can see how it works. The next thing also, you can use this pie chart to represent the what? To represent the hypertension. Can you see pie chart distribution of what? Of hypertension. So can you see now? No. And also yes. So no is having 90.3. That 90.3% is saying no. That means that does not have hypertension. And also you can also have this type of diagram. You can see different colors. This is the type of things I want. Use different colors, different background, different images. So the more code you write, the more robust you make your assignment to be, the more you convince me to give you the mark. So now you go to add disease. Add disease. This is the add disease. Can you see? Add disease. Having heart disease does not have heart disease. Does not have means 0. Having heart disease means 1. 276 have heart disease. So can we now see? That means heart disease can also contribute to stroke. All these factors are the ones that contribute to stroke. That's why I'm discussing them. Heart disease can be a factor that contributes to stroke. Look at the pie charts. On that pie chart, they're ever married. So if you have ever married, can also contribute to what? To stroke. Somebody who is married the marriage sometimes can be a factor that can lead to stroke. So that is what we want to do. And this is not that it has been established. You have to establish it for me in your research. And that's what we are doing now. So you can see these percentages, you can see this. I think you can see work type. You can see the work type, even work type, private, self-employed, children, government job, ever worked, never worked. You can see this thing now. You can see this. Then also this one now, you can see pie charts, can represent the private work, self-employed, children, then government job, then never worked. You can see the resident type of residence they are engaging in. Can you see now? So can we now see average glucose level? Can you see now? Average glucose level. Can you see the BMI? Can you see the BMI? So can we now, after you do that now, the next thing is that in our data sets, this one is because I have already known that data contains some missing values. So, and I want to try to fill it up, to fill the missing value up. In your home, you have to write out the code to determine the missing value. Because after you have done the EDA, the next thing is pre-processing. Under the pre-processing is what we call missing value. You have to determine the missing value. You write the code to determine missing value. If the missing value exists, then you now find a way to solve that problem of missing value. If it does not exist, then you report it that there's no missing value in the data set. After that, you look for outliers. What do we call outliers in statistics? Outliers means that when the data set is higher or is lower than others. Like for example, if you are in JS1 and some students in JS1, they are of the age 8, 9, 10, 8, 9, 10, 8, 9, 10, and you have somebody whose age is 42, and that person is in that class, that means that person is outlier to others because that age is too higher than others. So that's an outlier. Any age that is more extremely higher or extremely lower, then such thing is called outlier. Outlier also exists in a negative direction. What do I mean by negative direction is that if you are in a university now and they said the minimum age in university should be 16, and a student is coming to university at the age of maybe 8 or 9 or maybe 7 years, so such students will be coming as an outlier because that age is too small to others. So now I've run this code now just to fill in the median. This course I'm taking you now, you must have done this course in your previous course in Python. I'm only brushing it off just to ensure that what you have done is already part of it. Can anybody hear me? Can you hear me?
Yes, sir. Yes, sir.
You can hear me?
Yes, sir.
Okay.
Yes, we can hear you.
Okay, good. So another one is that you can run this code again. You can see this also line of code again. You can see what happened to this. So after that, you can go to smoking status. So what are the smoking status? So this is the status of the smoking. Then this is the code. This is the code. So after that, you go to this place. Go to bar charts. So you can go to stroke itself. Stroke itself is our target variable. Stroke is our target variable here. So in this place, 0 means no stroke. 1 means there is stroke. So these people having stroke. This is a percentage. 95% have no stroke, while only 4.8% have a stroke. So let us see what is happening. Okay, now let's see. Can you see now? So now stroke percent distribution based on gender. So I want to have stroke people based on gender. So from this place, you can see 0, 1. You can see that. You can see the result here also. Result here also means that stroke president distribution based on gender. You can see. So you can see stroke 0, 1. From the 0, you see how many people are having what? How many people are having stroke? I mean, this male. How many people does not have female? Because what I'm saying now. What I'm saying is that when you have under the no stroke means that at least from the no stroke, if there are 4,000, out of the 4,000, how many are male, how many are female? You can see that I'm going more deeper. This play also is showing that how many are male, how many are female. I'm going more deeper. This play also is showing this is an error here. And what is that error? That error is showing that you have an argument called data. And that has not been defined. Where's that data set? It has not been defined already. So if you look at what I'm doing here, when you are running a code, it's likely for you to see error in your coding. And when you see error in your coding, the next thing is that you have to look for the error and correct it. Cat got multiple values for argument data. Come to this side. So it's telling us that there is a data set, there is a data somewhere. Now it's saying got multiple values for argument data. Where the argument data is in line 4. Where is the line 4 here? This line 1, 2, 3, 4. This line, where is data? SNS codes. Okay. So cat plots. This cat plots it does not exist because it cannot be used for this type of situation. That's why. That means I will need to go and install this cat plots. But instead of doing that, I can remove this cell out. Let me remove this cell out because I don't want to go back again and begin to install. So I can remove that cell out. So you can also see this. So I think you can see this. So from here, also you can see this. You can see the stroke, presence, distribution. All these ones, they are still preliminaries. We haven't started working at all. All this area, they are still preliminaries. See the preliminaries? They are still preliminaries. So all this thing I'm doing is still preliminaries. Can you see how beautiful it is? Can you see this place too? Can you see this place too? Can you see this place too? So stroke presence distribution based on ever married. You can see that I take stroke and I'll combine with each of those variables one by one. That's what I'm doing here. I'm trying to do the graphics for them. All this thing I'm doing, we are still at the preliminary stage. We are still at the preliminary stage. So you can see stroke presence distribution based on what? Hypertension. Can you now see? Hypertension. So now stroke presence distribution based on hypertension. You can see this is 0 means nobody is having what? Stroke. So this one means there is stroke. And after all of that, you can see what happened here. What happened here? There is 0. You can see what happened. 0 means what? So 0 under this place, blue and green, and this color. So from there, you move on. You now do the correlation. What's the correlation? Correlation between X and Y. Okay. Let me move the correlation to give me this headache. So you now move down. When you move down, you now come to this place. Data pre-processing. All these things I've been doing since then, they are all called EDA. EDA, anything that deal with the descriptive statistics and deal with graphics, they are all called EDA. Now let's go to pre-processing. Let's check if your data sets contains missing value. Now we check like this. This one does not have missing value. It's 0 throughout. It means that no missing value data sets. Now let's encode. What do you mean by encode? The 0, 1, 0, 4, 5, 9, 5, 6, 9. Those are the column we want to encode. So, but then what encode means that I want to change their value from categorical into Representation. Maybe if it's maybe known, male, female, example is male, female. So I want to change the male to be 1, female to be 0. That's me of encoding. So what of encoding? I think all these areas you must have been taught in your Python class. I'm really trying to brush it up. So you won't say, what am I doing? So the next thing is what? Is to find this. Now we have encoded. You now copy the data again into DF2. You copy it again. Now I want to split that into what? Percentage. I want to split those percentage. So look at this. Look at the code. Look at the code. So I want to split the percentage. How am I splitting? I'm splitting into 10%. That means I want to take the train to be 10, the test to be the train to be 90%, and the test to be what? To be 10%. That's what I'm doing here. So later I will see you 20%. So this is machine learning, right? So the next thing is what to run this kind of code. And what is it giving you? It's giving you that I'm trying to use the standard scalar. Now I want to feed the model now. Random forest classifier. That's what I want to use. So this is the code for random forest classifier. When I run this code, you see that I have the result. This is the result I have. Accuracy score, accuracy percentage, and so on and so forth. And also I run this code. I have this one. In your own, you will report whatever you see in your data and you explain to me. You explain. This now code 2 is also available. Can you see now? You run this confusion matrix. They are called confusion matrix. So you run this also, you explain it to me. So also the decision tree classifier, you run it, you have the result here. And also what? You also have this. So that's how I run this code my one. Naive Bayes. I've used decision tree, random forest, naive Bayes classifier. So what is next again am I using? So next thing now, I want to split the game to 20%. 20% is 20% to be what? To be tests, while 80% to be trained. I'm training to 80%, I'm testing 20%. All this time, supposed to have known this time in your previous classes in your machine learning, which already have been taught. That's why I said anybody come to do this course must have known Python and done machine learning extensively. So you can see I'm running this code now just for you to know that this code and see the result. Later I will report the result now under this everything. I will report the results. You see how I will report the result now. This is naive Bayes classifier. Naive Bayes classifier. Naive Bayes classifier. So the next thing now is to run this also. You can see. Is anybody hearing me, please?
Yes, sir.
We are hearing and seeing,
Okay, that's good.
but somehow understanding.
Okay, that's good.
Somehow.
Somehow understanding that you have to listen to it and do extra work. By the time you run this code yourself, you understand it more.
Thank you.
Because this course is not for machine learning. The course is for cloud computing. I'm only trying to get you reminded about these aspects. So now I want to run the code now for the final results. Look at the final results. So 10%, 20%, 30%. Look at it. You have the accuracy percentage, 94.32. When is the 10%? Accuracy percentage here. Random forest happen to be the best. So it has the highest accuracy. When it was 10%. When it is 20% also, you see, random forest happen to be the best also, 93.84%. When it is 30%, random forest still perform best. So from there, you now interpret your results. That is the end of the course. Let me know if you have any question, please. Let me know if you have any question, please. Any question? Question, comments? Question, comments?
Well, Dr. Timothy,
Yes.
we appreciate, for me, I appreciate the lecture so far.
Right.
I know that I will not deny that we have not had an introductory aspect of Python. We did, but it's just that we always being confronted with issue of time and run and the time available and the exposure we had. So even in this one now, you have even gone deeper. I want to tell you that some of this analysis that you are doing, some of them, the different kind of analysis. Then I know we did this maybe missing values and all the rest of them, but using these different analytical tools or models or functions that you use that talk about different kind of tests.
Okay.
Some of them we didn't get, I don't know, others are here because I can see some of my classmates, in this class. So we may not have gotten to, that extent. And that's why I said that somehow we are seeing, we are hearing, but somehow understanding. But we are adult men. I know we will still go and do more research so that we understand more, because that's what we are here for. So that is it. I so much appreciate the exposure that even in this computer, even in this cloud computing, the cloud computing here is even trying to expose more. To me, I don't know of others. Thank you.
All right. Thank you very much, Prof. Thank you, Prof, for your comments. Any other comments, questions, suggestions, or something else? Anybody else? Comments, suggestions? Okay. If there is none, that means at this point, I would like to close the class. And since I've already shared this material with you in Google class, so please go to your Google class. You will download the materials there, sit down with it, ask questions. If you have any questions, by the time you are doing it, you can snap it and bring it to the WhatsApp group. I will still attend to you there, because by tomorrow also we are. Okay, Prof.
Here's a little more. I would also suggest that some of us in this class may have better understanding by virtue of their previous exposures, other than maybe previous exposures that may not be the institution where we are. So maybe understanding. In that case, I may also say there's nothing wrong if you may share us. I can see up to 13 of us. I also suspect that we may be more. If we may be grouped in terms of maybe 2 or 3, that may also help the weak ones, some of us that are weak, so that we can also catch up what is going on here, even in our assignments, to also help us so that we're not, you have told us now that tendency of 0, there's also tendency of 100%. Thank you, sir.
All right, I understand you. But at the same time, you need to understand the fact that this course is not even for treating this aspect of machine learning. By the time I start tomorrow, you will understand what I'm saying better. You understand that I just brushed this area for you, so that by the time I get to web design, you will not be lost completely. So you try to find your route one way or the other. That's why I'm trying to brush to remind you of what you have been taught previously on this course. So as far as this course is concerned, this aspect is still like preliminary aspect of it, though it's a very good segment, but at the same time, it is not the main cloud computing. So where we are going now, by tomorrow now, I will do the regression, and from regression, I will move straight to web. When I go to the web, then that means I've entered the cloud computing. So the same thing, the same time tomorrow also, you are still going to do Docker. So that's why I said tomorrow class is divided into 2. You have the first one from 3:30, then to 4:30, 1 hour. After that 1 hour, another will start by 5. I'll give you 30 minutes to rest. Another will start by 5. By 5 tomorrow, you start by 5, you end by 6:30. Or by anything past 6. So that first one is when I deal with this remaining aspect of machine learning, and I'll go into web straight. But that second one is dealing with Docker. That's another area entirely, under cloud computing, Docker. But I'm going to give you my assignments under this machine learning and web design separate. And that assignment will carry its own weight. So if you have any question, please you can ask again. Or when you are doing it, if you cover any issue, you can bring it to the group. Please refer to the group, I will attend to you.
Good day, sir.
Good day to you. Thank God, Israel.
Yeah. Yeah. So I observed we did import a lot of libraries, but some of them we are not captured. Do we need to import most of all of these while building?
Do you have anyone that is not
for the machine learning, like the scikit or stats, statistics at both statistics at ST, scikit or stat imports HI2 or the contingents and so on? We need an ggplot because we didn't use them.
Well, no problem. My own is just that, you know, I did not ask you to cram this code to your brain. But whenever I want to do machine learning, I know that I will carry all my libraries and put into one cell. Either I use it or I don't use it. I don't put them there, whim, and I'm running. That is all. Okay. So it's not compulsory. You make use of it, and it's not. It's not also not compulsory. So that's my own style. I just carry it and put it here. That's all. So either I use it or don't use it. There's no offense for it. Nobody will crucify you for not using it or for putting it there. Okay. If there's no question or suggestion again, so I would like to close the class and wish you well. Please go through what I've sent to you. And the note for tomorrow will be shared either this night or tomorrow morning. So by the grace of God. There are two separate classes tomorrow. The first one takes technically from 3:30 to 4:30, an hour. While the second one starts by 5 to 6:30, 1.5 hours. The first one is concluding this aspect of machine learning and web design. The second one is basically for Docker. We are starting Docker. And I think I've given you some intro aspect of it in your Google class. So please go to Google class and know more about this course. God bless you all. We're going to finish this course latest by second week. I want to finish by 10th or 15th of December. So I will not give you assignments. I'll give you your exam. After the assignment, they'll give you your exam. One assignment, one exam. That's what I will give you. And once I give you that, you do your assignments probably for 10 days. Then your exam may take maybe 15 or 20 days. Depends on what I put there and the time I'm setting it to questions. Any comment, please? Any suggestions, comments, observations, questions? Okay, if there's none, on behalf of Osiri University, Nebraska, US, and the Vice Chancellor of the university, the chairman of the university, that is Professor John Osiri, I would like to close the class and see you other day. Thank you, and God bless you all.